me start with a very simple question. Does PySpark actually run in Python? Most people confidently say yes. And that's exactly where Spark interviews go wrong. You can know DAGs, you can explain stages and tasks, you can even talk about shuffles, and still fail this one question. In the previous video, we understood how Spark executes job. In this video, we are going deeper. We are going to understand where Spark actually runs and why Spark is built on JVM and what role Python really plays in PySpark. Once this clicks, you will never say PySpark is slow without explaining why. This video is not about execution flow. It's not about DAGs, stages, or tasks. This video is about runtime, where Spark lives, where memory is managed, where code actually executes. If you understand this, and everything else in Spark starts making sense. Here's the most important mental model you need. Spark is a distributed JVM application. When you submit a Spark job, you are running a Python code across a cluster. You are launching multiple JVM processes across machines. The driver is a JVM process. Executors are JVM processes. Memory allocation happens inside JVM. Threading happens inside JVM. Garbage collection happens inside JVM. This is why Spark performance is so tightly connected with JVM behavior. Spark is not a Python system. Spark is a JVM system. Python is just one of the ways you talk to it. Now let's talk about memory. Only what matters for Spark. Spark stores data as JVM objects. Those objects live in heap memory. And heap memory is managed by JVM garbage collector. When the garbage collection happens, executors don't slow down, they stop. Tasks don't partially execute, they pause completely. This is why long garbage collection pauses can make Spark jobs feel randomly slow. This is also why Spark tuning focuses so much on memory. Not because Spark is inefficient, but because JVM memory pressure directly impacts execution. Most Spark performance issues are actually JVM memory issues. Now, a very common interview question. Why did Spark choose JVM instead of Python? The answer is not popularity. It's not syntax. It's not developer convenience. Spark chose JVM for execution reliability. The JVM provides mature garbage collection. It provides high performance multi-threading. It provides just-in-time compilation. And most importantly, it allows Spark to expose multiple languages API on top of one machine. Python was never designed to be a high performance distributed execution runtime. That's why Spark didn't build its engine in Python. It built the engine once in JVM and exposed the APIs on top. This slide clears up most of the PySpark confusion. Spark has two layers, the engine layer and the API layer. The engine layer is written in Scala and runs inside JVM. This layer handles execution, memory, and scheduling. On top of that engine, Spark provides APIs for Scala, Java, Python, or R. These APIs do not execute Spark logic. They describe work. The engine is the only thing that actually executes work. So PySpark is not a different Spark. It is only a different engine. It is just a Python interface to the JVM engine. Now let's answer the most misunderstood question. Where does PySpark actually run? Your Python code runs on the client or driver side. Python builds instruction. Python defines transformations. Python sends requests. Python does not manage Spark memory. Python does not execute Spark tasks. Python does not control executors. The JVM executes Spark operations. The JVM owns memory and CPU. The JVM runs on all the worker nodes. Python never owns Spark data on the executors. This single sentence explains a huge amount of Spark behavior. How does Python talk to the JVM? Through a library called Py4j. Py4j translates Python calls into the JVM calls. It serializes objects, it maintains communications between processes. Py4j is not Spark. Py4j does not optimize anything. Py4j does not execute tasks. It is just a bridge. And every time you cross that bridge, you pay a cost. A serialization cost, process communication cost, cost of context switching. This is the hidden price of PySpark. Now let's talk about Python UDFs from a runtime perspective only. Spark data lives in JVM memory. To execute the Python UDFs, that data has to leave the JVM. It gets serialized, sent to Python, processed in Python, and then sent back to the JVM. This is expensive. Serialization is expensive. Process switching is expensive. Python has a global interpreter lock. This is why Python UDFs are slow. Not because Spark is bad, not because Python is bad, but because Python UDFs escape the JVM runtime. So let's end with one clean mental model. Spark runs on JVM. Python only describes what you should do or what should happen. When your computation stays inside the JVM, Spark is fast. When your computation leaves the JVM, performance drops. In the previous video, you learned how Spark executes job. In this video, you learn where Spark runs and why Python behaves differently. If this video clicked for you, Spark interviews will start feeling very different. Thanks for watching. See you in the next dive.